Alright, so today we're going to talk about projectiles. Projectiles help us solve questions like this. If a cliff jumper is running 5 meters per second and jumps off a 44.1 cliff, will he make it into the lake? His life depends on your answer. So, projectiles are what we need to solve this. Projectiles involve two different things. Gravity pulling down and the speed of the runner as he jumps off the cliff. So, there's two formulas involved here. First of all, we'll talk about the speed of the runner. That's horizontal. How far will he make it is all determined by horizontal. The formula for any horizontal motion and distance is d is equal to velocity times time. Okay? The other one is vertical. This is gravity constantly pulling him down. So that is acceleration. It's accelerating him down. So the formula we use whenever we're dealing with acceleration is distance is equal to 1/2 acceleration times time squared. So the thread that connects both of these that you have to remember whenever you're doing a projectile is time. Both of these involve time. So time is the same. Whenever the cliff jumper jumps off the cliff, the amount of time he's falling for, is the amount of time that he's moving forward for. Those are the same. So, if you were to apply that to this question, for example, we would want to start with finding the amount of time he would fall off a 44.1 meter cliff. So let's start with that. We know the distance, or the height of the cliff. We're also going to end up knowing gravity, because gravity's acceleration is always 9.8 meters per second squared. We're going to look for the amount of time that he'd be falling off that cliff. So, let's start with the height of the cliff, which is 44.1 meters. Acceleration, which is 9.8 meters per second, as you remember acceleration, the rate of change in speed, and we're going to solve for time squared. So 1/2 of 9.8 is 4.9. So I'm just going to do that step right away. 4.9 meters per second squared is equal to 44.1 t squared. Now I'm going to divide by 4.9 on both sides to get t squared by itself. And when you do that, you'll find that it works out very nicely for us. This, of course, is meters. Meters cancel here, and you're going to end up with 9 seconds squared is equal to t squared. Now this part trips a lot of people up, because a lot of people have forgotten how to get rid of a t squared. Okay? T squared, to undo a squared, you have to square root. Okay? We could also remember that because it gets rid of the second squared, it turns it into just seconds. So t is going to be equal to 3 seconds. Now that we know that, we know exactly how much time this cliff diver would spend falling. That's the amount of time they have to make it forward into that lake. So now let's do that last part of this question, which is just distance equals velocity times time. We've done this many times. And the question is, will he make it past the 12 meters and into the lake? So distance equals velocity times time. The time, remember we already found, is the amount of time they're falling for. So, to find the distance, we're going to take the velocity we originally had up here, 5 meters per second. That is the velocity that he's going forward when he jumps off the cliff, and multiply it times the time we have right here, 3 seconds. These seconds are going to cancel, and we're going to end up with a distance of 5 times 3, which is 15 meters. So, if this jumper is able to move forward 15 meters in the 3 seconds that he was falling for, is he going to make it into the 12-meter lake? Yes, he will. So, yet again, remember, projectiles, whenever we're dealing with projectiles, anything being launched through the air off a cliff, we always have its horizontal velocity that's making it go forward. So that's from the velocity it started with. And we always have its vertical acceleration, which is from gravity. If you remember those two things and these two formulas, you'll be able to solve any simple two-dimensional projectile. In the future, we'll talk about projectiles that are launched at an angle off the cliff, but we don't need to worry about that now. Just worry about horizontal and vertical.